Hi all, welcome to Learn Code Repeat. Today is the day 2 of the November challenge. The name of the problem is Insertion Sort List. Let's look into the problem. So the problem states sort a linked list using insertion sort. So here they have given the graphical representation of insertion sort, and we'll go through one example for insertion sort, and the algorithm is mentioned here. What needs to be done? Insertion sort iterates consuming one input element each repetition and growing a sorted output list. At each iteration, insertion sort removes one element from the input data, finds the location it belongs within the sorted list and inserts it there. It repeats until no input element remains. So the example given here is 4213 and the expected output is 1234. So let's see this example. So in insertion sort, it says that in each iteration I, swap a of I with each entry is larger to its left. So what it means is, let's say we have two pointers I and j. Okay, so we have to swap each entry to its left until all the entries to the left is in sorted order, right? So in here initially I and j will be at the same position, then we'll increment I. So now I is here and j is also here. Now I and j is at the same position. Now I need to compare each value of j with the previous value of j, and I need to do this until j is greater than or equal to 0. Once j is equal to 0, I need to reset j to I. Okay, so here I will compare 3 with 4. So j will come here after that. So it will be this way: 3, 4, 1, 2, and j will be here, right? Now since j equal to 0 and I is here, I will increment the value of I. So I will come here and j will be reset to I. Okay, again I will do the same process. I will compare a of j, that is array of j value, with the j minus 1 value. So 1 and 4 I will compare. I will replace this 1 with 4. So 1 will come here and 4 will come here and j will be here. Okay, I will decrement the value of j. Now again I will compare j with j minus 1 until j is greater than or equal to 0. So 1 and 3 I will compare. So I will swap j and j minus 1. So here it will be 3 and here it will be 1 and j will be here. Okay, now since j equal to 0, I need to increment I and I need to reset j to I. Okay, so now the array is 1, 3, 4 and 2 and my I comma j is here. Okay, again I will do the same thing. Now if you see the value to the left of I, right, that is 1, 3, 4, all are in sorted order. So till this point we have been able to sort the array, right? So now again I will do the same comparison, j with j minus 1, so 2 and 4. So I will swap and I will decrement the value of j. So here there will be 4 and here there will be 2 and j will come here. Okay, again I will compare j with j minus 1. So here the value will be 3 and here it will be 2, j will come here. Okay, now 2 is greater than 1, which is as expected. So I will reset the value of j to I and I will increment I, which is more than the array length. So that means at the end I have the value as 1, 2, 3, 4, and that's what is expected, right? So this is what insertion sort does, and the complexity of this is O of n square, because we are going through twice in the for loop. It's a nested for loop for I and j pointer. Okay, so this is for arrays, right? How we can use insertion sort for arrays. So the idea here is to make sure that all the entries to the left is in sorted order. Okay, so all the entries to the left of I is in sorted order. Now let's see whether we can use the same idea for our sorted list problem. So the list, right, let's say this is a list, 4 points to 3, points to 1, points to 2. This is a singly linked list, and let's say my header pointer h is pointing to 4, and let's say I have a previous pointer, right, let's call it as p, which is initially pointing to a reference variable 0. Okay, it can be any value. So the idea here is that we can have this pointer pointing to the value which is in sorted order. So this can be my left pointer, right, that is left to the head. So I'll try to point this node to a value which is in sorted order. So initially my p will be null, it's pointing to null, right? So what I can do is I can place this 4 here and p will point to 4, right? So p is the previous pointer that I am holding the reference, and initially it will point to 4. Okay, so to make p point to 4, right, that means I need something like this, p to 4 to null, right? I need something like this. So that means I need to remove this reference, which is head dot next reference, as whatever is the value of my p dot next, right? And also my p dot next will be my head value, right? And after that my head pointer should move to this particular node, right, which is basically head dot next node, right? So in short, what I'm saying is I'll save head dot next to a temp variable, and then I'll point head dot next, right? I need to remove this, right? So head dot next should be pointing to my p dot next, right? So that's what I'm doing here. Head dot next will be pointing to previous dot next, and then my previous dot next should be pointing to the head, right? So that is the next step here, previous dot next pointing to head, and then my head should point to head dot next, which I saved it in the temp variable, so head equal to temp. Okay, now this is the main step that we will be doing. So let's say this is now removed and my current pointer is this way, right? So this is now head is removed from here and 4 is removed from here, right? Now the linked list is this way, 3 1 2. Okay, now again I need to move this 3 to this previous pointer, right? But I need to place it in a way that it's in sorted order, right? So that means when I'm moving it, right, I need to check whether this value is less than my previous dot next. Okay, if it is less than my previous dot next, so my previous dot next, again it will be something like this. It will use the same formula where temp equal to head dot next. So temp is, so let's say temp is this, temp is 1, then head dot next equal to previous dot next, right? So previous dot next is 4, head dot next equals to previous dot next. That means after 3 dot next equal to previous dot next, which is 4, right? And 4 is pointing to null, right? And then I'm saying previous dot next equal to head. Head is this still, right? So previous dot next is this, right? So now this is removed and the new formation is this way. Okay, and then I need to move my head to this particular point, right, which was temp. Temp was pointing to 1, right? Head equal to temp. So now my head is here. This is removed, this is removed, right? And this reference is also removed. So my new formation is this way. Now again I'll check if the head value is less than my previous dot next. Okay, now here the head value is less than my previous dot next. Okay, so again I will do the same step and I will have p points to 1, points to 3, points to 4, and then it is null. Okay, and my head will move here. Okay, now my head points to 2. Now I'll check whether my head is less than previous dot next. Now that is not the case. Okay, let's say after 2 I am having one more value as 5. Okay, so here it is not the case, right? So my p should move to previous dot next, right? So that means before this point I need to have a while loop which will check and move the previous pointer until to the point where the head value is less than previous dot next, right? So p pointer will now move to here. So currently previous dot next is 1, so from here it will move to here. Okay, and this value is greater than head dot next. That means head dot value is less than this value, so we can place head before this, right? So here, right, my previous is now moving to here, right, but I still need a reference to this starting point, right? So let's say I will have a dummy previous, something like that, which will point to the starting point, right? So my dummy previous is pointing to the head, which is pointing to 3, and this is the same point where my previous is at now, and then is pointing to 4, and then it's pointing to null, right? Rather previous is now at here. So I am having a dummy previous pointer whose next is 1 and previous is at 1 and previous dot next is 3. Okay, so I am checking head is less than previous dot next. Yes, so my previous dot next will be equal to head, so it will be the same this logic. So after this I will have this dummy previous is pointing to 1, which is pointing to 2, which is pointing to 3, which is pointing to 4, and then it is null. Okay, and my previous is still pointing here. Now once I did this, right, and my head points to now 5, right. Let me remove this part. So my head now points to 5, right. So my previous dot next is 2. So again I will have that while loop where my previous will move until my previous dot next is greater than 5, right. So my previous will move till here, right, and it won't find anything that is greater than 5. So I'll move my previous dot next until it's greater than 5 or it is null. So my previous now will move here, right, and at the end I can directly append 5, right. Okay, and once this is done I can directly return this value, right. So for that I need to again reset this previous to this dummy previous. So that's the importance of this dummy previous, so that it has a reference to the head. Okay, so I can reset at the end my previous to this dummy previous, and I can directly return previous dot next at the end. So it will start from this particular value. Okay, so let's try to code this. So here head is null or head dot next is null, then return head. Now I will have that temp previous defined and the previous pointer defined. Now I can use the while loop until head is not equal to null. So the first condition I will check is if previous dot val is greater than or equal to head dot val, then I will reset my previous counter to temp previous. So once I have done that, right, once I know that my previous is either at the correct position or it is at the start of the pointer, right, then I can check whether my previous dot next is not equal to null and previous dot next dot val if it is less than head dot val, right. If this is the case, then previous equal to previous dot next. So we are doing this to make sure that my previous pointer points to the correct place so that I can insert my head value at that place. Okay, so we are doing this movement of the previous pointer accordingly. So once that is done, then we'll move the head value to the correct place of the previous pointer, right, in this particular list. So this is the same thing that we did earlier, right. So the thing that we did here, I'm using the same logic to make sure that I can remove the reference from this particular part and I can add the reference to the previous list part, right. And after the while loop I can return temp previous dot next, because this temp previous is the pointer that points to the head of the temporary list that we created, right. So let's submit this. The code is accepted and it's at the range of 98% faster. So the runtime of this algorithm will be O of n square, because we are again moving the previous pointer till I am able to find the correct place to insert the head. So this is same as the insertion sort where we were moving the I and j pointer, right, where j pointer was decremented, right. Similar to that, here we are increasing the previous pointer based on where to place the current head value. So the logic is somewhat similar here, and the algorithm takes O of n square time and the space complexity is O of 1, since we are using only 2 pointers, right. Hope you like the video. If you have any questions, please write down in the comment section. Thank you.